Myself, Dr. Niranjan R.S., Assistant Professor, Department of Physics, Government First Grade College for Women, Valaneshipura. Today, I am going to discuss about the band structure of nanomaterials in the unit nanoscale system. Band structure of nanomaterials. Nanomaterials are the materials having size in the range of 1 to 100 nanometer. Band gap is the energy gap between the valency band and the conduction band. Consider an example of silicon. Electronic configuration of silicon is 1s2, 2s2, 2p6, 3s2, 3p2. Neglecting the influence of the inner shells levels, 2n electrons will fill all the 2n possible s levels, and 2np electrons will fill one third of the possible 6np states. Discrete energy levels are formed when we bring the atoms close to each other. 2n s states and 6n p states will spread into the respective 2n and 6n discrete energy levels, where n has the value of 10 to the power of 23 per centimeter cube. The separation between the discrete energy levels will be very small, and therefore the energy levels are closely spaced, are treated as quasi continuous states, and are called energy bands. If you look into the figure, that is the graph of interatomic spacing versus the energy. Here we can see the non-degenerate energy states. As the interatomic spacing decreases, we get degenerate energy states. As the degenerate energy states increases, energy gap decreases. The 2n states will be completely filled with 2n sc electrons, whereas 6n p states will be partially filled with 2n p electrons. As the interatomic spacing decreases further, the energy gap between the two bands shown in the figure 2 decreases as and when the interatomic between the atoms become very large. The energy band structure then depends on the crystal structure of the material and the electronic configuration of the atoms constituting the material. For small enough interatomic distance, the S band and the P band overlap to give a total of 8n allowed levels, that is 6n P levels and 2n S levels, out of which half will be occupied by 4n electrons. That means 2n S electrons and 2n P electrons. These electrons are then could not be identified as S or P electrons of individual atoms. Rather, they would belong to the crystal as a whole. For this reason, the above mentioned elements, the elements such as carbon, silicon, germanium, etc., are tetravalent in nature. All the lattice spacing as shown in the figure 2, the bond structure would consist of completely filled valency band with 4n valency electrons in an upper vacant band called conduction band separated by an energy gap known as forbidden gap. This PPT is prepared using the references mentioned here. Thank you.